Okay, so we've been working on greatest common factor. Now we're going to actually factor out a greatest common factor. Factoring as a verb, you guys can think of similar to dividing. If we're going to factor out something, we're going to divide out something. Okay, so let's see. The question is, why is it helpful to factor out the GCF from a polynomial? Consider this polynomial. Negative 12x cubed plus 18x squared minus 27x. First, step one, we're going to find the GCF of the terms if there is one. So let's go ahead and start with our coefficients. We have a negative 12, an 18, and a negative 27. So in the last video I said one approach you could take is look at your three coefficients, find the smallest one. Does 12 fit into the other two terms? If so, that's your greatest factor. 12 does not fit into an 18 and it does not fit into a 27. So what do you do from there? Well, if you take that smallest number, or that smallest coefficient 12, let's list the factors of 12. 1 times 12, 2 times 6, 3 times 4. We already determined that this 12 was not a common factor because it didn't fit into the other two terms. So let's just go down the list. And we're looking for the biggest one, so I'm going to look at the larger factors. Does 6 fit into 18? Is 6 a factor of 18? It is, so that's good. Is 6 a factor of 27? Does it fit into 27? It does not. So we're going to cross off the 6. Let's move on to 4. Because we already know that 4 is a factor of 12. Is 4 a factor of 18? Does it fit into 18? It doesn't, so we're going to cross it off. We have to find the one factor that fits into all three numbers. How about 3? 3 fits into 12. Is 3 a factor of 18? It is, because 3 times 6 is 18. Does 3 fit into negative 27? It does, because 3 fits in 9 times. So 3 is part of our GCF. And then we have some y's to consider. We've got, nope, they are x's, just kidding. X to the third, x squared, x. Find the term that has the least number of x's right here. Do all the other terms have at least an x? Yep, this one has an x plus an extra. This has an x plus a couple extra. So that means that x is part of our GCF. That's the most number of x's that they have in common. And then the other thing we said is that if your leading coefficient is negative, you're going to make your GCF negative. Okay, so we have identified the GCF. Now we're going to factor it out of each term of the polynomial. So let's rewrite the polynomial. Negative 12x to the third plus 18x squared minus 27x. When we say factor out, we're going to divide out a negative 3x. And we're going to divide that out of every term. This is factoring it out of the entire polynomial. When we do this, we are going to write the GCF down, put a parenthesis after it. And I'll explain the structure after we kind of simplify this. But you always write your GCF, then a parenthesis. And then what goes inside our parentheses is going to be what we have after factoring that negative 3x out of every single term. So we have right here, negative 12 divided by negative 3 is a positive 4. X to the third divided by x. When you are dividing the same base, you can keep your base and subtract your exponents. We end up with x squared. Next we have an 18. We're going to factor out a negative 3, so divide it by negative 3, which is negative 6. We have an x squared divided by x, so keep your x, subtract your exponents. That'll be x to the first. And then we have a negative 27 divided by a negative 3. When we factor that negative 3 out, we get a positive 9. And then if you have an x over an x, essentially they do cancel each other out, and so we have factored out the negative 3x. So our answer in factored form, this is what we call factored form because we have factored out a negative 3x. This looks like a monomial times a trinomial, and that's exactly what it is. When we're factoring, it's like we are undoing multiplication. So if we were to multiply this back in, distribute that, we would get this negative 12x cubed plus 18x squared minus 27x. So factored form is going to look like something we should multiply, but we leave it like that. One more thing I just want to make a note of. When you factor out the negative 3x, the stuff we had left over, 4x squared minus 6x plus 9, there should be no common factors in that. If we notice that there's a common factor, let's say all three terms had an x, then we've made a mistake somewhere. Either we didn't find the greatest common factor, we didn't factor out enough, or we made a mistake while actually factoring it out. Okay, let's practice a couple more. We're going to factor out the GCF from each polynomial. What that means is we have to identify the GCF first. So when we identify the GCF, let's look at the coefficients. The coefficient of this term is a 1. This coefficient is a 5. This coefficient is a negative 22. So what is the greatest factor that those three terms have in common? Well, if one term has a 1 as a factor, and that's the biggest number, they're just going to have a 1 as a common factor. They won't have anything else in common. Now let's look and see, do all three terms have x's? They do. That means they have x's in common, but what's the most that they have in common? So go to your smallest. This is an x to the first. This does not have any more than that, so that's the most that they would have in common. So 1x to the first. Now we're going to factor the 1x or just the x, you could write it either way, out of this trinomial. So we're going to factor an x out of every term. Now remember, the x goes out in front of your parentheses for factored form. X cubed divided by x, subtract those exponents, you get an x squared. 5x squared over x, that 5 is not going to change, so we're going to have plus 5. And then x squared over x leaves you with x minus that 22 is going to stay. And then if you have the x over the x, those will cancel each other out. And here is our factored form. Now let's do a check. Do we have any common factors in our parentheses? Do all three terms have x's? Nope, so that's good. Is there a common factor for 1, 5, and 22 that we missed? There is not. So this will be our final factored form. All right, so last one, we need our GCF. Look at our coefficients first. We have a negative 16, a 28, and a negative 20. Identify the smallest coefficient. Does 16 fit into these other two terms? It does not, so our greatest common factor will have something smaller than a 16. So why don't we go ahead and look at our factors of 16 to see which of these are also factors of the other two terms. So 116, 2 times 8, 4 times 4. We just determined that 16 was not a factor of the other two terms. So let's see if 8 is. Is 8 a factor of 28? It does not fit into 28, so it's not. Is 4 a factor of 28? It is. Fits in 7 times. Is 4 a factor of 20? It is. It fits in 5 times. So that tells us that 4 is the greatest factor that all three terms have in common. So our GCF is going to have a 4. And then look at our y's. Do all terms have y's? They do, so our GCF will have a y. Y to the 6th, y to the 4th, y to the 3rd. The smallest one, y to the 3rd, that's the most that they all have in common. This term does not have any more y's than that. So y to the 3rd. And then if you remember, I said if your leading term, this leading coefficient is negative, make your GCF negative. All right, so now let's factor out a negative 4y cubed. So we're going to factor out of each term. And then remember, when we write factored form, the GCF we write down first, we put a parenthesis after it, and then we do our factoring. Negative 16 divided by negative 4 is positive 4. y to the 6 over y to the third. Subtract those exponents and you get y to the third power. All right, next term, 28 divided by negative 4 is a negative 7. Y to the fourth divided by y to the third. Subtract your exponents, you get a y to the first. Negative 20 divided by negative 4 is a positive 5. And then we have a y cubed over y cubed, which cancels, so our last 5 will not have any y's left over. Let's do our quick check. Inside the parentheses, do we have any common factors? We have a y cubed, a y to the first, and no y's in that term, so they don't have any y's in common. We have a 4, 7, and 5. Is there any number that fits into a 4, 7, and a 5? And because there's not, this is factored form.